right, welcome back to Mr. P Helps with Math. This is for calculus, and this is lesson number 3 of Unit 0, and we are going to be simplifying equations with fractions and rationalized numbers. So starting off with this warm-up, so we have kind of a basic question here. So whenever you're adding or subtracting fractions, you have to have like denominators. Now 4 and 7, the lowest common multiple would be 28. So I would need to multiply this by 7 over 7, and I'm going to multiply this side by 4 over 4. 4 times 7 is 28, 7 times 3 is 21. So this is the same as this. Added 2, this is also going to be over 28, 5 times 4 is 20. And now that the denominators are the same, now we can simplify. So 21 plus 20 gives us 41. So 41/28 is our answer. Now, when you're dividing fractions, you can leave change, leave the first fraction alone, change to multiplication, and change the denominator to its reciprocal. All right, so I'm looking for reducing, which I can't, so 2 times 5 is 10, 7 times 3 is 21, and there is our answer. Now, rationalizing, which is a lot of what we're going to do in this video. So I cannot leave square roots in the denominator, so we need to get rid of that square root. So we're going to do what's called rationalize. We are going to multiply top and bottom by square root of 3. And anything divided by itself is 1, so really we're multiplying this fraction by 1, if you look at it that way. So on the top we have 2 times the square root of 3, and on the bottom we have square root of 3 squared. Because there's 2 of them. Anything times itself is squared. Now, square roots and squareds are inverses of each other, so they basically cancel out, and then we have 2 times the square root of 3 over 3. And there is our answer. Okay, so section 0.5, so unit 0 in the 5th part. So we're simplifying, so fractions with rationalizing. So in this case, I'm going to put this over 1. I asked myself, what's the common denominator here? So, well, now they both have a factor of 1, and this one has a factor of x. So I need to multiply this side by x over x. And remember, once again, I'm really just multiplying by 1, as long as I multiply top and bottom by x, because x divided by x is 1. So I'm not really changing its value at all. So I'm left with x squared over x. So x times x is x squared. X times 1 is x plus 1 over x. Now we've got the same denominators. And that was the goal. The goal was to get the same denominator. So now I can add the tops, and that gives me x squared plus 1 over x, because of course the denominator stays the same. And then that's going to be my answer, because that's an imaginary x squared plus 1. So remember, you can't factor it unless it's minus 1. Therefore, it's going to have imaginary roots. All right, example number 2, I'm going to do kind of the exact same thing in this case, only I once again have 2 different denominators. So what I'm literally going to do is multiply both sides by the other denominator. 2x minus 1 and 2x minus 1. All right, so 2x minus 1 times 1 is 2x minus 1. And then this is going to be, so if I FOIL this times this, so 2x times x is 2x squared. And then 2x times 1 is 2x minus an x. Once again, I'm FOILing the outers and the inners. 2x minus an x makes just 1x. And then the last, negative 1 times 1 is negative 1. Now that I've done that, I've already done it over here. It's going to be the exact same denominator. And the numerator, 2 times x plus 1, is going to be 2x plus 2. All right, so now that I have done, and I have the exact same denominator, so now what I can do is I'm just going to take the numerators and I'm going to subtract them. So when I subtract 2x minus 2x, those basically cancel themselves out. And when I do negative 1 minus 2 more, that's going to give me negative 3. And there's our answer, and the denominator stays, of course, the same when you're adding things with the same denominator. All right, example number 3. So I see that this can be factored in the denominator, so I'm going to do that first. This is x plus 1 times x minus 1. And then notice that both denominators have x plus 1. So it'd be easier. I don't need to multiply both sides by the other's denominator. I really just need to multiply this side by x minus 1 over x minus 1. And that way both denominators have x plus 1 times x minus 1 as its denominator. Now this one was already like that, so that's just x plus, now remember I got to distribute, so 3 times x is 3x, and 3 times negative 1 is negative 3. And it has the exact same denominator. Now, okay, so now I can simply add the numerators. So x plus 3 more x's is going to give me 4x, and then there's no constants here, so minus 3 makes minus 3. And then we have this, which we'll once again remember is really just x squared minus 1. I guess I could have just left it that, x squared minus 1, or you could leave it x plus 1 times x minus 1. Honestly, it's the same thing, only factored. All right, example number 4. So this time we're going to rationalize because we have a square root in the denominator. So I want to get rid of that. So since the whole thing's in the square root, I'm going to multiply both top and bottom by the square root of x plus 4. And the purpose of doing that is that I'm going to end up getting x plus 4, square root of x plus 4 squared. And then on the top, we have 3 times the square root of x plus 4. Now, the reason I did that, once again, is because square root and squareds are going to be inverses of each other, so they're going to cancel out, leaving me with just x plus 4 as the denominator. And then the numerator, well, I really can't do anything about this because square root of x plus 4, there's nothing that I can take out of that. Now, you might be thinking, well, isn't 4 a perfect square? Why can't I do the square root of 4? It's because that's all one binomial. So you can only do that if this was multiplication. If it's addition or subtraction, you can't do that. Now, if it was x times 4, then you could split them apart and you could do the radical of each one. But that is going to be our final answer. That's as far as we can simplify it. All right, which brings us to the very last question. All right, so now this is that case that we have not seen yet, where we have, so imagine this was, I know this looks complicated at the bottom, but this is a binomial because of the subtraction. It's actually 2 parts. It's square root of x and square root of x plus 1. So this is kind of like having like x plus 1 on the bottom. So it's a binomial. Now, one way of getting rid of it when it's this way is to basically multiply by the opposite. And there, I'll show you basically as I'm going why that kind of helps and works out. So I'm going to do the opposite, which is instead of subtraction, I'm going to do exactly the same as the denominator, only with addition. So square root of x plus square root of x plus 1. And then, of course, on the bottom, because it has to be the exact same thing, square root of x plus 1. Okay, so now the numerator is just 1 times that, so the numerator stays, 1 times square root of x is square root of x, plus 1 times square root of x plus 1 is, of course, square root of x plus 1. Now, the bottom. I mentioned earlier that this is a binomial. So think of this, you can think of this as that times this, right? So when you're multiplying binomials, what you do is firsts, outers. So this would be first. These are things on the outside. These are things on the inside, and these things that are come last. So you have to multiply basically all of these terms by all of these terms. Now you can kind of see why we did what we did. Square root of x times square root of x is just x, because square root of x squared, the square root and the squareds cancel each other out. Now, outers. So we have square root of x times square root of x plus 1. Now, I could go ahead through that process and figure out what that is, but there's a reason why I did what I did. When I do the inside, which is square root of x times negative square root of x plus 1, the exact opposite, the outer and the inners are going to cancel each other out. That was the reason why I did the opposite. so that whatever this answer is, I know this, which is basically the same two terms multiplied by each other, it's going to be the opposite because of the negative sign in between. So I don't even need to worry about that, those two terms. The outers and the inners will cancel each other out. Then all I have to do is worry about the last. It's a negative times a positive, so I know it's negative. And then it's going to be square root of x plus 1. And then, of course, it's squared because it's times itself, right? Now, once again, like we've done in the past, square root of x plus 1 times and the squareds basically just cancel each other out. So you're left with just x plus 1 in this parenthesis. That's it. Now, that negative sign means you have to distribute that. So we now have square root of x plus square root of x plus 1 over x. Okay, so minus, so distribute, that becomes minus x. And negative 1 times 1 is negative 1. Okay, well, we can still simplify because look at the denominator. X minus x cancels, basically, they cancel each other out. And now you just have this divided by negative 1, which honestly I don't like to stay divided by negative 1. Dividing something by negative 1 just takes whatever's on top and turns it into a negative. So that's literally the answer. So the answer is going to be negative because it was divided by negative 1. Square root of x plus square root of x plus 1. And that is as far as it can be simplified using any of the rules that we have looked at. All right, thanks again for watching, and I think I'll look forward to the next video. Have a wonderful day, and see you later.